put that up there. If you were in any of the classes for day 2 that you didn't finish number 6, please refer to day 1's video. It's described there how we got this result. And we'll move on to 7. And we're only going to do number 7 of these 3 because the idea is relatively simple, what we're doing. And number 7's got the most fractions. And it is a proven method to determine if you have yourself some inverses. It's like checking your work. Like you're not sure, like you might ask me, like for one of your homework problems, am I right? Well, this way, if I'm not available and your book's not available and your examples aren't available, you can use this method to check to see if you're right. If you properly calculated the right inverse. So it is a proof, and you know what we do with proofs? We could use them in a court of law. Abraham Lincoln, he studied Euclid's Elements, which is full of all the geometric proofs and algebraic proofs that determine the foundation of mathematics. But unfortunately, when he lived, they thought the world was flat. So his ideas are for the flat earth, which we live in locally, but they had to come up with more proofs globally, you know, when they discovered that we live on a sphere. Okay. So that's how powerful proving things are. That's why I could not neglect showing you this. So it's really, really good for you. Maybe some of you guys have career goals to become lawyers. Math is a good place to practice proof. That's what you have to do in a court of law to win a case. Right? Either prove or disprove evidence. Right? So good stuff. Building a case for paying attention. Okay, you're going to need a couple of sticky notes. This first one we're going to use for the first part of the proof. And then the second one will be the second half of, and it's, yeah, I'm using the word proof, and some of you might like have a, I don't know what you call it when things scare you, like a trigger. Like you're scared of proofs because you didn't have success with them previously. Maybe that was when your brain wasn't as developed. Okay, I still, you know, my proof cup still needs more filling because you know, that's not my strength, but I'm not going to let it go. I want to be informed. Okay, so I'm going to just start out with a pencil. No colors on this one. If I can find my, oh, here it is. Okay. So first thing I'm going to define for you is this word in the sentence. It says, use composition to determine whether each pair of functions are inverses. You know what an inverse is. Where x and y are switched, that's the inverse. Create a new function. So they're saying this is the new function. Well, these are two different functions, maybe. We're assuming that g is the new function and f is the original function. So the word composition is when you place one function inside of the other and then simplify. So I'm going to start out with putting this new function inside of the original function, and it looks like this as far as notation. We put f parenthesis g of x and 2 parentheses. For me, like g is the basketball and f is the net, and I'm dunking the basketball into the net. Or you could think of where the x is on the f function, that is going to become the nest where I'm going to lay the g of x function egg. Trying to draw real life pictures for you to see this mathematical abstraction. So, and when you become the doer and you feel yourself actually involved with this process, you're more likely to remember it. Now, there's one more way I can note this. And depending on your math experience, especially if you've experienced the ACT, you might have already seen this notation or this one they fondly call fog. But that's not the letter O. It is an open circle. And if you see in math notation, I don't have it on my wall per se, but in math notation, that open circle implies composition. And that means I'm placing G inside of F. So, and then you write this, of X. You can leave the of X out, whatever. Okay, you could just see the word fog too. They're a little loose there with the notation. So let's actually do it. For F, I'm going to start writing the function. I'm going to put a negative 2 over 7, but instead of an x, that disappears. Don't rewrite it. Put a nest, a parenthesis, a hug. And in that hug goes this expression. Negative 5 minus 7 halves x. And then I close the hug because I'm done writing what G was. And then I go back to F again and finish its story. Minus 10 over 7. So I just took this basketball and shot it in this hoop. Poof. Now that's the easy part. It's the new part though. You didn't know you could do that. Now you know you could do that. Then you get to simplify. So it's really just a substitution. Like instead of x, I put the actual expression, negative 5 minus 7 halves over x. See, this x is this one, okay? This one like disappeared. And then we simplify. So order of operations, I would do what's in the parentheses first, where there's no like terms. So then I multiply next, and that happens to both of these terms inside. So negative 2 over 7 times a negative 5 is a positive. I think you know already. 10 over 7. And that's where a good calculator with a fraction button helps you if your, fractions are not your strength. Then when I take a negative 2/7 times a negative 7 halves, negative times negative is positive. 14 divided by 14 is 1. So I don't have to write the 1 as a coefficient. I just put the value of x, or the variable x. Okay, that's all that gets multiplied. Then I finish the expression out, 10/7. Then I check again, can I combine like terms? Yep, 10/7 minus 10/7 is 0, so all I have is x. And that's what you want to prove for this first half, that they are inverse functions. So we got the first one done. Now we're going to do the second part. Any questions about the Algebra 1 part here? Because this right here, this blah, 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 that's all just Algebra 1. The only thing I taught you in Algebra 2 is this new idea that you can put one function's expression into the other function. Like an egg into a nest, like a basketball into a hoop, whatever makes your heart happy. And I'm going to erase those. Go back to scratch again. I'm going to do the other part of the proof where I'm going to put this f function into the g guy. So it's written like this. I want the f function on the inside of the nest, or I can write it G little open circle f of x, or they call that one Goff. So you got fog and Goff. Taking notes? Taking notes? Taking notes? Okay. Because this one, remember, this is special. This lesson is special. You won't see it again for a long time, if any. So ACT mastery is happening here, or if that's not your point, you're heading on to pre-calculus, you're heading on to whatever next math. This is important. Pay attention now. Okay? Because the only new thing I taught you is this little guy right here. All the rest is old news that you get to practice. Okay, so G got started to write -5 minus 7/2, but instead of the x, I write a nest or parenthesis or a basketball hoop, whatever you want to think of it as, and then I put my -2/7 x minus 10/7 inside. So this guy went in there, right? Yeah. You see how it replaced the x with the expression. Now we get to use our Algebra 1 skills. Can't combine like terms, so we distribute that. Negative always goes with the number. -7/2 to both terms inside. So -5 comes down. Negative times negative is positive. 14/14 is 1. So I have just a plus x. -7 times a -10/7 is a positive. 7 times 10 is 70. Over 2 times 7 is 14. I didn't cancel, you know, I can just reduce here. What's 70 divided by 14? Anybody good at mental math? Calculator? 70 divided by 14? It's a plus something. What'd you get? 5. Perfect. Thank you. That helps. It's like moving the chess on the chessboard, chess piece on the board. You could say, checkmate. -5 plus 5 equals 0. 0 added to x is x. You just did your algebraic proof using composition to determine whether each pair of functions are inverses. Those were messy. So you see the messy and anything else will be simpler, as well as, why don't we do one with a no? Well, I want to get you on your homework so you can ask me questions. And it's just like studying counterfeit bills. I don't know if you know anybody who knows about counterfeit money. You know anybody who's in that field? Well, they don't study the bad bills. They study the good ones. So when a fake comes along, they know it right away. So that's what, if you know what a yes looks like, you just get X alone. Any other time, you don't get an X alone both ways, you know it's wrong. They are not inverses. Now, when I looked at those two, I guessed a no. Because I thought the signs didn't change. I was looking for the signs. Silly me. Because this guy is like a -2. It kept everything negative. So it fooled me too. So it's a good thing we went through the proof. Didn't listen to my conjecture. But you gotta guess, right? You're wrong. You're just like predicting the weather. Do they get fired because they're wrong? No. They just say, oops, I guess I missed that one.